We're entering the last chapter of the course now. We're looking at some trigonometry, but it's not trigonometry like you might have seen in the past. There's no right angles in any of these triangles. We're going to be using trigonometry to solve triangles that don't contain right angles. And today we're going to start with determining side length using the sine law. So in this section, we're going to focus on recognizing and describing an oblique triangle. I'll give you a definition of that. And applying the sine law, explaining how to use the sine law, and describing how the sine law is used in problem situations. So the outcomes we're going to cover, it's just one, really. Solve a problem using the sine law when a diagram is given. It doesn't sound like a heck of a whole lot, but it can be a lot of work. So we're going to start with our definition here for an oblique triangle. An oblique triangle is a triangle that does not contain a right angle. So we have two different types of triangles. We have right triangles, which contain a 90-degree angle, and we have oblique triangles, which do not contain a right angle. And oblique triangles can be acute triangles or obtuse triangles. And so then the question is, what is an acute triangle? An acute triangle is a triangle with three acute interior angles. So all three angles in the triangle must be between 0 and 90 degrees. An obtuse triangle is a triangle with one obtuse interior angle. So that means that one of your angles in your triangle will be between 90 degrees and 180 degrees. We can see on the right we have a 110-degree angle in this triangle. This would be considered an obtuse triangle. Also, it's important to note that when you have an obtuse triangle, the other two angles are going to have to be acute. In any triangle, two of your angles are going to be acute angles, and the third could be either acute, obtuse, or right. So I just want to remind you what sine is specifically. Given a right triangle like triangle ABC, you see below it's a right triangle. If I want to find the sine of C, so I'll just call it my pen here. All right, so I'm looking for the sine of this angle right here. I'm giving you the relationship here. It says opposite over hypotenuse. So we have to remember what opposite and hypotenuse are. Your hypotenuse is always opposite your right angle. It's always the longest side in any triangle. That's a right triangle, of course. So your hypotenuse is going to be right here. Always opposite your right angle. Your opposite angle, or sorry, your opposite side to your angle, I should say, is the one side in the triangle that does not touch the angle in question. So angle C, being down here, side AB doesn't touch it at all. So this is the opposite side. And just a reminder, the third side in a right triangle we refer to as the adjacent side. Okay, so whenever we label any triangle, we're doing it in relation to one of the two non-right angles. So in this case, we're looking at angle C, and we have the hypotenuse, which is going to be the hypotenuse no matter what kind of triangle we have, what kind of right triangle we have. For angle C, the opposite side doesn't touch it at all. And adjacent actually means touching. So the adjacent side is the side that is touching angle C, but is not the hypotenuse. Okay, so sine of C is equal to opposite over hypotenuse. So in this case, as I've mentioned, it's going to be AB over AC. Okay, so this sine law, which we haven't yet defined, but the sine law is used when triangles are oblique. In other words, they're not right triangles. So we use this the sine ratio when we have a right triangle, but now we're going to use the sine law when we don't have a right triangle. So for triangles such as these, the one on the left is the acute triangle from our previous page where we looked at the definition. Notice that all of the angles in this triangle are less than 90 and also greater than 0. And the second triangle, we have one angle that's obtuse, which is greater than 90 and less than 180 degrees. So both of these are oblique triangles. So we can find the length of a missing side in a triangle if we know one other side and two angles. So we need two angles and a missing side, and a known side to find a missing side. Down here, we have an angle right here, 37 degrees. We have another angle, 56 degrees. And we have the side that's located between those two angles. So we actually have an A, S, A triangle, because the side is contained between the two angles that we know. In the triangle on the right, we have one known angle right here, we have one known angle right here, and we have one known side. So we still have two angles and a side. So we will be able to use our sine law. But notice that the side that we have this time is not contained between the two angles. So when we have two angles and an uncontained side, we refer to that as an angle-angle side triangle, because following in a counterclockwise fashion, we have an A, S triangle. We can't skip any parts, so we follow the order of our given parts here. We don't go in the other direction because we have this angle missing right now. On the other one, I should have mentioned this at the time, we start at this angle right here, and we're traveling in this direction to get an A, S, A triangle. So here is the sine law. We've been talking a lot about it. Here we're actually getting the definition. In the sine law, the sides of a triangle are proportional to the sines of the opposite angles. So the relationship, if we have triangle ABC, as you see listed here, we can define all of our ratios of our sides to our sines of our angles. So A over sine A, you'll notice that they're opposite each other. A over sine A is equal to B over sine B, which is equal to C over sine C. So the side and angle labeling, first if you recall, you may remember this from earlier grades, we label sides in a triangle usually with lowercase letters, and we measure, or we label vertices in a triangle with capital letters. And the letters that correspond to each other are opposites on our triangles. So side A is opposite angle A, side B is opposite angle B, and side C is opposite angle C. So let's solve a couple of triangles. We're going to look at those triangles from earlier in the slides. The first one is this angle side angle triangle. So we want to find x in this triangle below. We're going to look for this angle right here. Okay, this is an ASA triangle because I have an angle, I have a side, and I have an angle. The side opposite, or sorry, the angle opposite side x is this one right here, which I'm going to call capital X. I also know that I have a 56-degree angle right here. And I have this side 10 centimeters. Now, in my sine law, I have A over sine A, capital A, is equal to B over sine capital B, which is equal to C over sine capital C. So what I'm going to want to do now is label all the parts of my triangle in relation to those. So I'm going to try labeling them that way now. So I'm going to call the 37-degree angle A, which means that X I'm going to refer to as little a. The top angle I'm going to call B, which means that the 10 centimeters is equal to B, little b. And I'm going to call the 56-degree angle big C, which means that the opposite side is little c. So if I fit the known values into my sine law, what I get is X over sine 37 degrees is equal to 10 for B over sine B, which is equal to C over sine 56. So the way it looks right now, we have a missing value from all three of our ratios. So it looks like it might not be solvable. However, one thing we have to recall is that in any triangle, the sum of the angles in any triangle is equal to 180 degrees. So I can find angle B because I know angle A and angle C. To find angle B, I'm going to have to subtract from 180 degrees the two other known angles. So 180 degrees minus 37 degrees minus 56 degrees. And that gives me a total value for angle B of 87 degrees. Okay, so when I go into my equation now, I have X over sine 37 degrees is equal to 10 over sine 87 degrees, because I know that angle B is 87 degrees. And I don't really need to do anything with C over sine 56 because I don't know what C is, and I would have to actually use the sine law to find it. So I'm not going to use that at all. I'm going to skip that ratio. I'm going to use just 2. And in any sine law question, you really only have to work with 2 ratios together. So my goal here is to find angle or side X. So this is my equation I'm going to use. So what I'm going to do now, I'm going to rewrite right over here, X over sine 37 degrees is equal to 10 over sine 87 degrees. And I'm going to multiply both sides of my equation by sine of 37 degrees. And what you'll notice now is that sine 37 and sine 37 on the left will cancel each other out. So what I'm left with now is x is equal to 10 sine 37 degrees over sine 87 degrees. Okay, and we're actually going to go to a calculator now and calculate that. I'm going to use the one that's here on my computer. So hopefully you can see my calculator here now. So I've got 10 times sine 37 divided by sine 87. So I'm going to type that into my calculator. 10 times, and with this calculator I have to put in the angle first and then hit the sine button. With your calculator you might have to put the sine 37 in as it's written, or you may have to type in 37 then sine like I'm going to do. Also, it's very important when you're doing this that your calculator is in degrees. You can see that my calculator here is in degrees. Make sure that yours is in degrees. Often if you have a scientific calculator, there's a little D or DEG at the top of your display screen. If it's written as G or R or GRAD or RAD, then you're in the wrong mode and you have to convert to degrees. So make sure that you know how to do that. So now I'm going to multiply 10 by 37, then hit the sine button. And I'm going to divide that by 87 sine. And that gives me a final answer of 6.03 for the missing side x. Okay, so x is equal to 6.03, or about 6.0. And does that make sense? Remember from chapter 5, when we were looking at side properties in a triangle, we said that the shortest side in a triangle would be opposite the shortest angle, or the smallest angle. The smallest angle in this triangle here is 37 degrees, and x is opposite 37 degrees. So finding a value of x equals 6.0, considering that B, which is the longest side in the triangle, is 10, does seem to make sense. So I think we're in a good position here. So now we're going to find y in the following triangle. This is an angle-side triangle. It's called angle-side, if you recall, because we know this angle, and this angle, and this side. So this side right here. So we're traveling in this direction. So if I want to find side y, the best thing to do would be, first off, to label our triangle again. So we've got triangle A, B, C. We got little side A, little side B, and little side C. Okay, so we're going to fill in the numbers into our ratio again. So we have A over sine 37 degrees is equal to B, which is 10 over sine 87 degrees, which is equal to y in this case. Y is equal to c over sine, sine c. So right now we know everything in the middle ratio. We want to find y, so we're going to ignore the first part of our ratio here. But there's just one problem right now, is that we have two unknowns in our last ratio, y and angle c. So just like in the last example, we're going to have to find angle c first. And again, the angles in a triangle still add up to 180 degrees. So we take 180, so c is equal to 180 minus 37 degrees minus 87 degrees. And that works out to, as I thought, 56 degrees. Okay, so we're going to fill that in here now. We have 10 over sine 87 degrees is equal to y over sine 56 degrees. So I'm going to, this time, multiply both sides of my equation by sine of 56 degrees. And what I'll notice is sine 56 and sine 56 will cancel. So we'll end up with y is equal to 10 sine 56 degrees over sine 87 degrees. So real quick, we're going to go back to the calculator again. I'm going to clear this out. Now I'm going to calculate this equation. And remember, the calculator has to be in degrees. So I multiply 10 times. For me, I have to type in the angle, then hit sine. 56 sine divided by 87 sine. And that gives me a value of 8.30. Okay, so that tells me that y is equal to 8.3 using my calculator. And once again, does that make sense in the context of this triangle? What you may have noticed is that this is actually the same triangle from the last example. We were just given different parts of it. Instead of being given what we called angle C here, we were given angle B this time. So angle C, I'll put it in here. Angle C is 56 degrees. From the last question, we found that side A here is equal to 6.0. And now we're saying that side Y here, or side C, is equal to 8.3. So again, using our relationship between the sides and angles in a triangle, 56 is the middle of the three angles in my triangles. It's neither the smallest nor the greatest. And 8.3 is between 6.0 and 10.0, or in 10. So it does appear that we've calculated this correctly, because the middle angle and the middle side are opposite each other. Okay, we're going to look at a word problem here, another example. So Elliot's family owns a house on the Gander River in Newfoundland. Their closest neighbor's house is 2.5 kilometers away. A surveyor uses a theodolite to measure the angles between the houses and a nearby communication tower as shown in the diagram. A theodolite is one of those surveying machines you might see on the highway often, what almost looks like a camera set up on a tripod, and there might be two, maybe a few hundred meters apart, and two people steering through them. Okay, so we're going to use the sine law to determine the distance from Elliot's house, which is on the left, to the tower, which is across the river, to the nearest tenth of a kilometer. So we know two angles and a side in this triangle, so we'll use the sine law. And we're going to draw the triangle modeling the problem. So we're just going to simplify, take away all the excess parts of the diagram, just simplify it as much as possible into just the triangle that we're looking at here. So in this triangle, what kind of a triangle do we have? We have a known angle right here. Then we have a side, and then we have an angle, all side by side. So I have angle, side, angle. Again. So this is a type of relationship that will be useful for sine law. Angle, side, angle triangles can be, values can be found from them using the sine law. Okay, so we want to find E to get the distance from Daniel's house to the tower. So we're looking for, here's Daniel's house right here, and here's the tower. So we're trying to find E, which is the length between Daniel's house and the tower. We must use the side we know and the angle opposite. So we know that F is a known side. We have that value of 2.5 kilometers. What we need to do then is find angle F. To find angle F, we use the relationship between the angles in a triangle. That is that we have 180 degrees is the sum of all the angles in a triangle, minus the two known angles, minus 65, minus 80 degrees. And that means that angle F is going to be 35-degree angle. Okay, so here we go. Now we write the sine law for this triangle. We know angle F is 35 degrees. We have the opposite side to the 35-degree angle. Right here. So we have an angle and its opposite side. We're looking for E, so we're going to use angle E as well. So in general, this is our sine law, but we don't need to do anything with D at all. So we only need two ratios. One includes the side we're looking for, side E, and the other must include side F because we know side F. We don't know anything right now about side D, so we can't really use it. So our ratio is going to be reduced to E over sine E equals F over sine F. Okay, so we're going to fill in the values we know into this ratio. We know that angle E is equal to 80 degrees. We know side F is equal to 2.5. And we know that angle F is equal to 35 degrees. Now what we want to do, again, is find E by itself. To do that, we multiply both the left-hand side of our equation and the right-hand side of our equation by sine 80. Because right now we have E divided by sine 80. To get rid of sine 80, we have to do the opposite operation, which is to multiply. Multiply and divide are opposite operations. Addition and subtraction are opposite operations. So what I have now is sine 80 and sine 80. They cancel each other off. So what I have now is E on the left side of my equation is equal to sine 80 times 2.5 divided by sine 35. So hopefully at this point you know how your calculator works. Whether you type in 80 sine or you type in sine 80, it depends on the make and model of your calculator. Your calculator must be in degrees. And when we type that into our calculator, it's going to look something like that. This is if, of course, your calculator needs sine before 80. Otherwise, it would be 80 sine and 35 sine. Okay, your answer is going to be 4.2923 and so forth. Okay, so apologies. That is my answer, right? The distance between Daniel's house and the tower distance between Daniel's house and the tower is 4.3 kilometers. Perfect. Okay. So to summarize this, we can use the sine law when we don't have a right triangle. And we can find the missing side length of a triangle if we know two angles and a side, using sine law, of course. So when we have two angles and a side, we can label our triangles as either AAS triangles or ASA triangles. And given a triangle ABC, the ratio, or the sine law says that A divided by sine of angle A is equal to B divided by sine of angle B, which is equal to C divided by sine of angle C. And we only need to use two ratios at a time. We don't necessarily have to set up all three. We use two at any one time to find a missing value. So in any example such as this, we're going to have to know three parts of the ratio to find the fourth.